Hello friends, I welcome you all to this class. This is mathematics class, and in this class we are here to continue our study of this topic we introduced in our previous class. We introduced the derivative of functions expressed parametrically, and I actually showed you how to do that using one particular example in our previous class. We are here to solve the second example. And in our previous class, I told you that if you have a function of this form, x is a function of t, y is a function of t. Remember, the variable t can change to any other variable. But x is a function of t and y is a function of another function of t, which means x and y are function of the same variable t. So they can give you an equation that x and y are functions of the same variable, and they may change the variable t to another variable. But the main thing there is that the derivative of y with respect to x is the derivative of y with respect to that variable, we have t in this case, divided by derivative of x with respect to that variable, that's the y dt, because we have t in this case. But in this example we are considering, they told us to find the derivative of y with respect to x if x is b cosine raised to power 3 theta, and y is equals to b sine raised to power 3 theta, where b is a constant, which means that x is a function of theta and y is a function of theta. So in place of t in this definition, we have what? Theta. So both x and y are the same, are functions of the same variable theta. So our work here is to find the derivative of y with respect to x. That's derivative of y with respect to x. By the formula we have here is derivative of y with respect to that variable. So it will be derivative of y with respect to the variable. What is the variable here? Theta. In this example, dy the theta divided by what? Derivative of x with respect to the variable. But what's the variable in this case? Theta. So we have derivative of x with respect to theta, the x, the theta. So we are going to perform this operation we have written on the board. So according to the operation, we have to differentiate y with respect to theta. So y is b sine raised to power 3 theta. But you know that y being equal to b sine raised to power 3 theta implies that y is equal to b sine theta all raised to power what? 3. What I wrote down here is that sine raised to power 3 theta is the same thing as sine theta all raised to power what? 3. And why I wrote it like this is that we are going to use chain rule to find the derivative of this. So according to chain rule, if you have a function which is raised to a particular power, we have a bracket like this. We have a function inside the bracket raised to a particular power. You have to differentiate what? The content of the bracket. So what do we have inside the bracket? What we have inside the bracket is what? Sine theta. So if you differentiate sine theta, it will give you positive cosine theta. Derivative of sine is positive cosine. Then you are going to use the result to multiply the derivative of the bracket. The derivative of the bracket. So what is the index of the bracket? 3. So I'll bring, using the power rule, you bring down the index, right? Then next you remove 1 from the index. So you write what you have. b open bracket sine theta all raised to power 3 minus 1. We'll come to x. You differentiate x with respect to theta. So we have that x is equal to, look at what is given to us. X is equal to b cosine raised to power 3 theta. So using the same analysis as I did in that one, so it implies that x is equal to b cosine theta all raised to power 3. So because cosine raised to power 3 theta is same thing as cosine theta all raised to power 3. So I'm going to use the same format. We'll differentiate the quantity inside the bracket. So the quantity inside the bracket is cos theta. Derivative of cosine theta is negative sine theta. So negative, we have negative sine theta. You put multiplication sign, you differentiate the brackets. What's the index? 3. You bring it down. Then you are going to minus 1 from the index. So you write what you have. B, open bracket, cosine theta raised to power 3 minus 1. We can simplify it to be, so 3b multiply cosine theta, I can have it to be 3b cosine theta, then sine raised to power 3 minus 1. 3 minus 1 is 2. So this gives us sine raised to power 2 theta. So that's what we have. Then all divided by, do the same thing here. Minus sine theta multiplied 3b will be minus 3b sine theta. Then cosine theta raised to power 3 minus 1 is same thing as, because 3 minus 1 is 2, so it will cosine squared theta. So it will be cosine squared theta. Cosine squared theta. Then if you have it like this, some things can cancel. We can simplify it. So of course, sine theta can cancel sine squared theta, reducing this to sine theta, right? Then cos theta can cancel cos squared theta, reducing this to cos theta, right? Then 3b we cancel 3b. We have minus here, right? So altogether we have, what is left up here is sine theta, and what is left down is negative. We have negative here. We have cosine. So negative cosine theta. But sine theta over cosine theta is what? Tan theta. So this will be negative tan theta. So negative tan theta is the derivative of this parametric function with respect to theta. So I'm expecting you in our upcoming class. See you in our upcoming class. Bye.